Yaskawa.
Welcome to the Sigma-5 tuning Quickstart video. This is Matt Pelletier, and in this video I will demonstrate how to use the auto-tuning feature using SigmaWin Plus. The system I'll be tuning you may have seen before in the Sigma 2 tuning class. It's the Rotary drive demo, and it uses the SGM GV09 motor with the Zero Max coupling directly coupled to a 10-to-1 load. The amplifier is a 400 volt SGDV 3R5, and the tuning challenge that we have is the same one as from the Sigma 2 tuning class. We have to move 240 degrees in 200 milliseconds with a 500 millisecond dwell, and the tuning goal is that we would like this machine to operate smoothly and quietly and to settle within 0.07 degrees of the commanded position with a settling time of less than 100 milliseconds. So at this point I am connected, the servo pack is on and is at default parameter configuration. So my first goal is just to get the out-of-the-box performance. Let's get a benchmark of the performance. And out of the box we are using the default tuning feature, which is called the tuneless function. But in order to do that, first I need to set up the amplifier and configure the parameters. And the easiest way to do that is to use the parameter wizard. So I'll go up here to parameters and set up wizard. And you'll notice that everything's grayed out except the encoder selection. So I'll use encoder selection first, and I'll confirm that the fully closed encoder, the linear scale, is not used. So I'll leave that unchecked and hit apply. And now that opens up these other buttons that are not grayed out anymore. First I'll need to set the control mode to position control. So I'll click control mode and scroll here to position control, pulse train reference, hit apply. Notice when I hit apply it shows that there's a change here with a green highlight. Next then is the reference input setting, and I'll leave the first couple screens here at default. These screens have to do with if you are connecting an external controller with a pulse reference output, then what type of format would you want. So I'll leave those at sign-in pulse and positive logic. And here's where this wizard really makes things easy. We can set the electronic gear details, which means we can define how far the motor moves with one pulse. So I'll click next, and first I can define the mechanical system by choosing one of the options here. And as you may guess, we have a rotary table, or round table as they call it here. So we'll choose round table. We don't have any gearing, but you can always put a 1-to-1 gear ratio there. And that is the first thing they ask for, the gear ratio, so I'll leave that as 1-to-1. Since there is no gearing, it's just a directly coupled motor to the load, and I'll click next again. And then this is the part where it really makes it easy. All you have to do is choose the reference unit, and you don't even have to calculate the electronic gear ratio. That'll be calculated for you. This looks like a fine reference unit to me. This reference unit means the minimum motion. When you have one pulse from the controller, this is how far the machine will move, which is 0.001 degree, 1/1000th of a degree. And then the other field to enter here is the position completed with. This is tied to the coin signal. You can see that down here. So if we want to have a position completed with, or in position window is another name for it, we had said we had wanted 0.07 degrees. Well, if our reference unit is 0.001 degrees, I will need 70 reference units to equal 0.07 degrees. 70 of these will equal 0.07 degrees. And I'll hit apply, and that's done. Now there are some options under encoder setting and stop method, but we'll just leave those at default. The only other thing I want to do is go to the I/O setting and mask off the over travels. It's also very easy to do that within the wizard. You go to input signal setting. You see I do have over travels here. And so for pot and not, the over travels, I will set those to off. It's as easy as clicking always off and OK. And hit apply. And now you can see that these three areas have been changed. So the final step here is to write this to the controller. So we click Save Write, and you can even save a backup file of the parameters that are already in the drive. But I'm just going to write these parameters directly into the amplifier. So I'll hit Write. This is acceptable. And I do need to cycle power, so I'll click OK. And I'm just going to finish this wizard. And you also notice that there is an alarm A941. Change of parameters requires cycle power. There's a very easy way now in Sigma-5 to cycle power. You just use this right here, the software reset button. You don't have to actually physically cycle power. So just click that and execute. It takes about 5 seconds. Now, when you finish the software reset, it does say that you should always reconnect to SigmaWin Plus. Now, really the only reason for this is if you've remapped inputs, you can see it still shows that there's pot and not mapped to the inputs. So everything will be updated when you reconnect. So as best practice, I'm just going to go ahead and do that, do file reconnect, and connect to that same servo pack again. And now that I've reconnected, you can see that pot and not are not mapped to these pins as they were before. So now my first goal is to find the out-of-the-box tuning performance. And so I'll use the program jog operation under the test run menu. And here are some safety warnings you should carefully read. And what program jog allows you to do is to program a simple move profile. And so I'm going to put in the profile that we're tuning for, which is 240 degrees. And so that's the move distance. So 240. And that is in reference units. So I need to add 3 more zeros since the reference unit is 0.001. The speed was 400 RPM. Now, when you see min -1 as the unit in this software, that means RPM. The acceleration deceleration time is 100 milliseconds. And we wanted a 500 millisecond waiting time between moves. And if you hit apply, you can then verify as the graph updates to show the move that you've programmed in here. So you hit apply, and you can also have this move repeat a few times. And maybe I'll have that repeat 20 times. So this is what the motor is going to do when I hit run. Now, before I run it though, I can simultaneously set up the trace function to graph this move. So under the trace menu, I go to trace. And to set up the trace the first time, you need to go to the setup button. And SigmaWin Plus has also really improved the setup screen for the trace function, because you can go to the auto setting and choose one of the settings here as according to what you want to graph. So what I'm going to choose is this first one, monitors position completion, because I want to see the settling time or the position completion time and in the forward direction. Now here's the key, you have to hit the set button, and you can see that that fills in all the other data and triggers and I/O that you can graph automatically. Now I only want one change from this, which is that instead of graphing the position error, I would like to graph the feedback speed. And I'd also like to see a little bit more of the move. I don't think 125 milliseconds here will be enough. So I will instead have 1 full second of move here by entering 1000. I'll click OK, and then this will be saved for the rest of my SigmaWin Plus session. I hit start, and it says waiting for trigger. It's just waiting for the motor to move. So back to program jog. I'll start the process and hit run. Servo on. You can hear the servo went on. And execute. There's some oscillation at this point. Now I'll just let that finish. And then servo off. So this is the result of the tuning less function. And while tuning less does help a little bit, you can see that it's not perfect. It is still noisy. It didn't apply any notch filters or anything. But let me see if I can get some reading on what the position settling time is. So to do that, I'll go down here and change the time scaling. And you can see here, this is where the position reference stopped. And then coin means it went into position, but you can see the coin signal is up and down because the motor is vibrating. So I'll measure it by using the cursors with the cursors button up here. And so it looks like we were in position right about here where the coin signal started to go low, but the commanded move was to stop right here where the position reference speed went to 0. This used to be called reference pulse speed in Sigma 2. It's the same signal. So this is the settling time between these two cursors, and it comes up with 113.21 milliseconds. That, with tuning less here, it's very close to the 100 milliseconds that was required, and if it wouldn't be for the vibration, it might have even been a suitable performance. So even without doing anything, we already have pretty decent performance except for the noise. But I think we can get it better by using the auto-tuning function. To use auto-tuning, we will go to the tuning screen. So under the tuning menu, select tuning, and another set of warnings you should read. And click execute. Now you cannot use the tuning less function and auto-tuning at the same time. So this window is just a prompt for you to turn that tuning less function off. So I will click yes, change that, OK. And then there's a warning that you will have to cycle power, so click OK. And now I have the requires restart warning again, so I'll close these windows so that I can get to the software reset button. I'm not going to save the graph. So restart right here with the software reset, take advantage of that feature, and execute. So now, according to this caution, I should reconnect, but since I did not change any inputs, I really don't have to do that, so I'm just going to skip over that this time. Right now, we are not using the tuning less function. So let's go up to the tuning menu, and we'll try the tuning function again. We'll execute the tuning function, and now we're able to see this first screen. Now, starting up here at the top, you could try to independently find the moment of inertia ratio, but we found that it works just fine to find the moment of inertia ratio during the auto-tuning procedure. And within the auto-tuning procedure, you have two choices. You can either tune with a move that's given to the servo pack from an external controller. They're showing a little picture of a controller sending the move to the servo pack here. Or what our preferred method is to use the no reference input selection and let the servo pack use its own specialized pre-programmed moves and auto-tune to those. So that's what we would recommend that you do. So I click the auto-tuning button, and it does give a warning, and this warning is just telling us that we haven't found the inertia yet, but we know that we're choosing to do it that way, and we will find the inertia within the auto-tuning procedure. So click OK. And we now are presented with this dialog, and the first field here is conditions, and the options are a moment of inertia is presumed and a moment of inertia is not presumed. Okay, what this means is, do you already know the inertia ratio, or do you want the auto-tuning procedure to calculate the inertia for you? So if you don't know the moment of inertia ratio, you want to choose setting 0. The moment of inertia ratio is presumed. What that means is the moment of inertia ratio is calculated. Instead of presumed, put in the word calculated. It makes a little more sense. The next option is mode selection, where you have 3 choices: standard, positioning, or to prevent overshooting. And since we're focusing on positioning time, we'll choose positioning. And there's a description area here, so the other modes also have a description. You can try to choose the one that best fits the description of what you're trying to do. Mechanism selection is next. You can use belt, ball screw, or rigid model. I think belt and ball screw are pretty clear. Rigid model is what we have here, where you have a load directly coupled to the motor. So we'll choose rigid model. And now finally, distance. This is the distance of the auto-tuning move. It will be doing a move that's 3 revolutions back and forth as the maximum move distance. So this number of reference units will equal 3 revolutions of the motor. Now if you have a mechanism where 3 revolutions would be too far, maybe you're close to a hard stop, there's no way to get away from it, then you might want to change this to a lower value. Otherwise, we suggest you just leave it at the default of 3 revolutions. So since we have a rotary axis, we can go as far as we want. We can just leave that at default and click Next. So you can see here in this screen the order of operations that it will take: find the moment of inertia, and remove oscillation, and find the best gains. So let's just get it started here and click servo on. And you can hear it, it's oscillating. Click start tuning. And you just sit back and let it tune. So right now you can see it already applied a notch filter right away. It does that as soon as possible. It finds the moment of inertia. Now it's looking for oscillation to see if it needs to apply the anti-resonance or vibration suppression filter. And you can tell by the result here that it did not need to do that. Now it just is going through and by trial and error finding best gains. So it does a series of different moves. And tuning is completed. So we'll click Finish. And we'll click Finish again. That's the end of auto tuning. Now there are other advanced adjustments, but that'll be another video. And you can even see what it found for the inertia here, 911, and that's pretty close. It's a 10-to-1 inertia was the design of this machine. But the true test is going to be in the graph. So let's pull up the graph again. So we go to Trace, Trace, and I'll move that one over to the right like I had before. And we also need to pull up Program Jog again. And you see that Program Jog is set up from before because these are parameters, PNs, in the drive. So this Program Jog will be saved here for the rest of the lifetime of this drive unless you change those parameters. So I'll move that over a little bit and I will start the graph. It's waiting now for the trigger. We will then run the Program Jog and hit execute. And I think you can tell already, just by looking at the far away, the 30,000 foot view here, that it looks very good. Let's just zoom in a little bit. I always like to use the time scale to zoom in. And so there's our deceleration with the position reference speed coming down to 0. This is when the motor should have stopped. And here's where the motor actually did stop, where the coin signal goes low. Coin signal here in red. Where the coin signal comes low is when we are within 0.07 degrees of the final position. So I'll put the cursors up here again. And you can see our final result is just around 20 milliseconds. So we have beaten our tuning goal of 100 milliseconds by 5 times. We have a number 5 times lower. And if you look here at the graph again, you can tell that the torque is very smooth. You know, it has some ripple, but even listening to it, you can tell that it's very quiet. So I think we can agree that the Sigma-5 auto-tuning does what it says it can do. It's very high performance, very easy to use, and does a really great job. So, thank you very much. This concludes the Sigma-5 tuning quick start video. Thank you, Nishant.